Hello everyone, this is our new unit, first section of Unit 4, Day 1 on Similarity. This is Dilations and Scale Factor. So up at the top of your page you can go ahead and fill in these blue words that you see. A dilation is a proportional enlargement or reduction of a figure through a point called the center of dilation, and scale factor is the actual size of the enlargement or reduction. Now, in class, we talked about, if you were here, how a lot of us have had our eyes dilated. What that means is that they put those little drops that make your eyes super uncomfortable, and your pupils get bigger so that they can shine the light in and see if there's any damage in the back of your eye. That's the kind of dilation that we're used to hearing about, but there's plenty of other representations of dilations outside of math class. For example, blueprints are a great demonstration of dilation. The blueprints that you see for buildings, or even like the furniture that your parents probably put together in your house, those pictures are not to scale. You know, they're bigger or smaller depending on the object that you're working with, but they are proportional because they're a dilation. Otherwise, they wouldn't make sense for what you're looking at. If any of you eat cereal at home, my personal favorite is Mini Wheats. A lot of people seem to like Captain Crunch, which I don't understand, but you know, whatever floats your boat. On the front of cereal boxes, they tend to have those giant blown up pictures of the cereal, and then in little tiny writing next to it, you can see where it says enlarge to show texture or not to scale, something along those lines, which is another example of dilation. They made it bigger so that you could see the texture of the cereal and want to buy it. Now, before you go through this lesson, you should watch the video that's attached before this. It's a quick 2-minute intro. It'll really help you kind of get a visual for some of the stuff that we're talking about. But if you've already seen that, go ahead and continue on with this. Alright, so to dilate an image, kind of like they talked about in the video you watched, you need to multiply the scale factor by both x and y coordinates. Alright, so you can't just do it by one, otherwise you're going to have a warped looking weird picture. You got to do it to both of them. So if I've got an actual set of points, I can do that. So in this one we have a is -2, -3. My scale factor, it tells me, is 2, which means all of my numbers have to be doubled essentially. So -2 times 2, -3 times 2, because those are my original points. My scale factor is 2. A prime, that's this little apostrophe, we say prime for that, is now -4, -6. And I apologize if your video seems a little shaky. We had some issues with Smartboard today, so it's not as solid as we're used to. Same thing with the next one. We have -4 times 2, that's going to be -8. 0 times 2 is still 0, so b prime is -8, 0. And same thing for c. 0 times 2 is still 0. 1 times 2 is going to be 2. So those are the scaled up points for this picture because we're basically doubling everything. So I'm going to put the original in black. So -2, -3, this is point A. B is right here. And C is right here. Should make a nice triangle. Okay, and since my scale factor is 2, my picture should be getting bigger. So if it doesn't happen like that, I know I did something wrong. So -4, -6 is down here. Make sure you label it A prime. -8, 0 kind of goes off the graph, but we can still label it there. And then C prime. Again, notice everything has a letter and possibly a prime symbol. Okay, and like I said, it doubles in size because you have a scale factor of 2. So everything is doubled, just like you did with the multiplication. Okay, pretty basic math. It might even be stuff you recognize from previous years, or it might just be easy enough to catch on, hopefully. If not, we'll still do another example. But this is an example of enlargement. When the scale factor is more than 1, you're going to get a bigger picture, kind of like the cereal we talked about. All right, so this one now, we have a scale factor of 1/3, which means it's going to get smaller. All right, well, when we're working with fractions, it's a little different, but let's try it with point A. So -6 times 1/3. You're still multiplying. I don't care if it's a fraction, it still works the same. Turn your 6 into a fraction so you can multiply and just multiply straight across. You have -6 times 1, which is -6. 1 times 3 is 3. Well, fraction really means divide in math. So in reality, it's -6 divided by 3, which is -2. The reason it works that way is because when you multiply by a fraction, it's the same thing as dividing by its reciprocal. In other words, if I flip these numbers, I get the equation up above. Dividing by a number is the same as multiplying by its reciprocal. So you can either do all the fraction work or you can divide by 3. You're going to get the same exact answer no matter what you do. But go ahead and pause and do that for all of these numbers. These ones are incorrect. On your page it says 6, 6 and 6, -6. So just be aware of that. There's a little mistype there. So go ahead and fill those in, and then you can push play and finish up with what I've got. All right, and again, you could have either done that by multiplying by 1/3 or dividing by 3. Both of those are equal to each other, so it doesn't matter which way you do it, as long as you do it to all of them, x and y coordinates. So I'm going to do the pre-image in black. So -6, +6 is right there. That's point A. And B is down here. C is right there. And D is over here. And you can plot those points yourself. You don't have to wait for me to do it. You're perfectly capable of plotting points on a graph. In fact, it would be good practice to make sure you do know how to do that. Okay, and if we did this correctly, the prime points should make a smaller rectangle. So -2, -2. And make sure to label it. The reason you gotta label it is because otherwise you don't know which one the original is. You might because you just did it, but nobody else is gonna know, especially not the person you might be turning it into. And just as predicted, we get a smaller rectangle. Feel free to pause here, take notes, and then we can move on to the next section whenever you're ready. All right, flipping over on the back side, this is the rule for finding scale factor. So in the last two problems, they gave you scale factor. They told you it was 2 and 1/3. This time we're going to practice when you don't know scale factor. So you got to take one of the sides from the new shape, doesn't matter which side, as long as the shape is proportional. And then a side from the original, when you divide them, they give you scale factor. It's a pretty easy formula. Makes sense because to get the graphs that we did previously, we had to multiply. Opposite of multiplying is dividing. So in this example, I'm going to match up my sides. 6 matches with 15, and yes, it has to be 6 over 15, because remember our formula is new over original. 10 matches with 25, and last 8 with 20. Oops, that's a 0. Okay, now right now those fractions don't look the same because I haven't reduced them, so I need to do a little bit of work to figure out if I can actually get the scale factor. You do want to keep it as fractions if possible, but decimals are appropriate as well at times. So I can divide both of these by 3. That means I'm going to get 2/5. Okay, well, that's looking good so far. Now I need to get the same exact fraction for all 3, because if I don't, A, I did something wrong, or B, the shapes aren't actually proportional. They're not similar. But since it tells us they're similar up here, I'm going to assume that I've done something wrong if I don't get the same fraction. This one I can divide both by 5, and I get 2 over 5. Good. Same fraction so far. Last one. Hopefully in your head you're thinking of what numbers you could divide by. And hopefully you came up with 4. You could divide it by 2, but that's not the biggest common factor. Remember, you want to get it down to simplest form. So pick the biggest number you can divide by. And again, we get 2/5, which is the scale factor of these shapes. Okay, now is 2/5 bigger than 1 or less than 1? It's less than 1, which makes sense because the original to the new gets smaller. We said that if it's less than 1, it's going to be a reduction. Okay, copy this down and then go ahead and try example 4. You're going to do the same exact process, but this time you're going to have to actually divide the numbers. You won't be able to reduce the fractions like we did here because they're not whole numbers. So simply divide it on your calculator. You'll get a decimal. Like I said, that's okay. It's just not going to be the nice fractions like we're used to. Whenever you're ready, push play, but try it out first. See if you can come up with the correct fractions by following the new over original formula. Alright, there are your fractions. 15.6 matches with 6.5. Obviously the same with 19.2 and 8. If you divide them, you get 2.4 for both, which is the scale factor. Makes sense because the picture is getting bigger. If it's bigger than 1, it's going to be a bigger picture. Go ahead and check your work. Make sure you did it correctly, and then we'll move on to the last example. Okay, go ahead and take a look at that. See if you can figure out how to find the scale factor of these points on your own. You probably can figure it out without my help, so I'll give you a little time. Pause here, figure it out on your own, and then push play when you're ready. Alright, K prime is the new shape, or the new point, I suppose. K is the original, so it's the same exact process. Just make sure you match X with X and Y with Y. So 9 is going to go over 3, 12 is going to go over 4. Remember, it's new over old, so you got to do it this way. If you flip it, you're going to get the wrong fraction. 9 divided by 3 is 3. 12 divided by 4 is also 3, so it was a scale factor of 3. Okay, and you can even check. This is actually like the video that we did. 3, 4 became 9, 12 in the video. Same exact process, just multiplying by 3. Some of you might even be able to look at those numbers and figure out that it's a scale factor of 3. Just make sure it's not a scale factor of 1/3. Okay, if you're going from small to big, it's got to be a number bigger than 1. If you're going from big to small, it's got to be a number smaller than 1. So pause here, get caught up. The remaining problems on this page of your notes are your assignment to do. So 4 problems total, not too bad.